Hello, this is Ariella Levine. This is my problem 3 homework assignment. I've chosen to do problem 11.7 from the textbook, which is largely based on a lot of the information provided in example 11.3. The only difference is a sim table. They want us to change the inspection probabilities to pass and determine what kind of impact that has on the outputs, the batches required, the days to complete, and when we need to start production. So before we get into that, though, I'd like to go over some of the specific details that came from 11.3 that I used to base my information off for problem 11.7. So what's happening here is it's all about the Wozak company. So they produce drugs, and one of their best customers has requested 8,000 ounces by the due date 12/1. Problem is, Wozak company has a couple of unknowns. They know they want to meet the requirements of 12/1 with 8,000 ounces, so they're trying to determine how far back they need to start and how many batches they're going to need to make. So those two pieces of information, let's start with the batches. There is a triangular distribution on those batches. At minimum, each batch will produce 600 ounces, most likely to produce 1,000 ounces with a max value of 11,000 ounces. Now, that's for every single batch. Each batch takes a number of days to be produced, which is also an unknown. Occasionally, they can have anywhere from a batch take 5 days to produce to 11 days to produce. And they each have different probabilities. So day 5, it could take 5, there's a 5% chance it would take 5 days. It would be a 30% chance to take 8 days. And you can see the rest on the table here. The third thing is the inspection. They have an inspection process, right? If the batch does not pass inspection, it can't be used at all. It can't be utilized towards a total. So it may be a 9-day batch, and if it doesn't pass, then it's going to be thrown out, and we're going to have to just add those days to the total number of days that need to be completed before we can fulfill the order. So that's a lot of the information from 11.3. The problem 7 requirements was running a variety of simulation probabilities. So in the original example, it was a probability of pass of 0.8%. In this new question, we have to use anywhere between 0.6% probability of passing and 100% of passing. And we're doing 1.1 increments for each of these, and we put them all together on a sim table to run 5 simulations with 1,000 iterations each. And those specifications were detailed out in the book, again, under example 11.3. So let me take you through some of the math that I put into this formula so you understand where some of the numbers are coming from. So we've got different batches labeled out here, and we base our simulations based on these numbers. Now, we have a risk discrete formula saying, okay, what are my chances, given each of these probabilities with these days, that we're going to, how many days we're going to output. So I've set it up to say, okay, well, compare those, give me a risk discrete based on that, and it's turning back 8 days. And it says, okay, great. I have 8 days now. Now I've got a second unknown saying, what am I going to produce from each batch? So I've got a risk triangle set up saying, okay, take these 3 and give me back a variable in between of what my most likely yield is going to be. Now, based on that, I'm going to have to say, oh, well, hopefully that wasn't like that all the way across. No, it was not. Okay, so I have to say, is this batch going to pass test? And again, in this example in particular, I've got 0.6% chance of it passing, and it'll generate either a yes or a no. And again, if it doesn't pass inspection, we don't get to count it. So because it did not pass in this case, I have 0 yield. So it took me 8 days, I got 900 units, and after all that, I get to keep none of it. And then in this formula here, I say, well, is that enough? Do I have enough in my cumulative, which in this case, I didn't, to meet my 8,000 requirement? If no, we had to keep going. Very exciting, I know. So this one I say, well, refer to that enough column. If it's enough, I don't need to continue forward. All of this will stop once I hit yes down here. As soon as I have the correct number of units, we stop. We don't need to do any more batches. But there's so many variables that go into it. So again, we'll run the same formula, risk discrete, if that value is no. If it's yes, it stops everything and becomes blank. So we do the formula again, we do the days, we do the yield, we do the does it pass, and it's just a random thing again, yes, no, and then we add all that up and say, okay, well, I'm going to start adding whatever my new yield value is to what I've already accumulated, and you're going to tell me if that's enough. And we finally get it all the way down here, and again, this will tell us how many batches it requires, the number of days summed up here that it took to do it, and backwards math from there, how many total days it's going to complete. Now, we've also got some risk functions going on here, determining, based on my runs, what's happening. Now, I am having some issues with this risk table. I ran it as a singular value from 11.3 and had the same example issues, and it didn't get better when I did the table, but at this point, I'm unsure what to do to fix it, so I have to submit my my program as is. I've gone through the steps twice from the book trying to determine where my formulas were going wrong. It gets very interesting. I'm going to run it for you because it looks like the values are coming out correct from the simulation, and then everything reverts to this 8,900 value. No matter how many times I refresh it, does not matter. It always turns out to be 8,900. My pass changes every now and then, but I never get any different values besides this 8 and the 900, except when I run the simulation, and then it goes away real quick. So to be honest, I'm not entirely sure what is causing that, but I'm going to run it for you so you see what I'm seeing here. And again, 5 simulations because of our sim table. So it's beginning its run. We see the yield values moving probably as they should be, and my days varying as well. But as it keeps processing, my values are being replaced. Well, if it keeps running, my values are being replaced automatically with 5 and 8 based on God knows what. It just keeps overwriting it. I see the values move as they should here, but 5, 8, 5, 8, 5, 8, 5, 8. So based on that, my results are not ideal. I do see different stats here, and one of the questions from problem 7.7 was, should we be increasing the number of batches for one of these, for the different inspection probabilities? And based on some of the random values that I've seen from this, yes. Some of them are under 25, most of them have been over, so I did increase my table values to go up to 37, and thus far I think that's actually one of the highest batches I've seen. And again, these were just risk values I set up to measure the number of batches, average days, and this became especially more important as I couldn't actually see these values changing, which is A+. Not sure why that's happening, but yes, in answer to question 7, it should be more important to raise the maximum due to probably higher chances of failing. As we have a lower inspection probability, we probably have more batches that need to be thrown out, which causes us to have to create more batches. That's just, again, a theory that I have based on the data. I apologize already for the fact that I could not get the sheet to behave the way I wanted. I hope I was able to provide more information about what I was seeing. The stats, I believe, are still true and hopefully will provide enough of an answer to show that my calculations were done correctly. Thank you very much, and if you do have any responses about what I could have done differently to make this behave appropriately, please feel free to share. I am actually very curious. Thank you.